good evening, or good afternoon, depending on where you are, as always. And as always, I'm based in Poland. My name is Jakub. Here is 9 p.m. I'm very happy to be able to speak with you today about, well, basics about dependency injection and with a splash of Spring Inversion of Control. What are those? How do they differ? If they differ at all, etc. etc. So you might want to call it back to basics because we are going to talk about basic stuff. But even though if you are an advanced Spring and Spring Boot user, treat it as a different perspective of what you have thought about Spring and how it works under the hood when it comes to the very basic stuff, be it dependency injection and inversion of control. And if you are not familiar with Spring at all, actually that's a session for you because we are going to cover it from very scratch and what kind of problems does it solve and how those problems relate to what you, dear listener, might be facing on your daily work. All right? So sleeves up and let's jump onto code. Before that, I will just friendly remind you that this is our weekly show. It runs every Wednesday at noon Pacific time, so please mark your calendars because we are going to see each other next week and then in 2 weeks and then in 3 weeks and so on and so forth. Let's go back to our dependency injection and Spring IoC stuff. Let's imagine we have such a class. It's called Payment Title Provider, and believe it or not, it provides titles for payments. Actually, for now, currently it just waits for a while because, well, we haven't finished the implementation yet. But we know that we might face some exception and we want to log that exception and return something. Otherwise, if that's a success, we want to return the payment title. So imagine such a code. How we are going to log things? Well, we need a dependency to a different component, that different component being a logger, right? So one way of providing this dependency would be, let's make it a private field of our payment title provider. That would look as follows: private final logger. Let's call it logger, and it should be, for instance, new. Let's pick console logger. Why not? Alright, so far so good. And this we are able to uncomment this line and actually log somewhere to the console our error message. Makes sense so far, right? But you know, probably our enterprise system, it's built from more than one class. So we have more classes. We have payments details provider. We have clients details provider. We have, what else do we have? We have, as you can see, authentication manager. We have payment configuration. We have payment gateway. We have something more like claims remote service, etc., etc. And I will bet that payment title provider is not the only place where we would like to log things. Logging is actually a common thing. So probably when we are talking about payment details provider, we would like to log something as well. Like this. Log payment details provider is working. Just like with the previous example, we've picked console logger as implementation of logger. So now we have two classes and both of them are using console logger as a current implementation of logging mechanism. Imagine 3, 4, 5, 6, 10, 100 or maybe even 200, or maybe 1,000 classes that use console logging. Those 1,000 classes, they will have to have a dependency to our console logger. That makes sense, right? So what is the problem? Well, imagine you would like to change the implementation. Probably you don't want to log to the console on production. Probably you want to log to the console when you run it on your machine. When you run it on test environment, you want to log to a file, maybe to somewhere in the cloud. I have no idea where, but probably it's not going to be to a console. So what's the problem? The problem is now you have to change the implementation, for instance, to file logger. If that's one place, well, that's good. That's nice. That's easy to do without any problems. We can do that. We can redeploy our software, right? But as we mentioned, we have 1,000 places to change. That's going to be a problematic job. We have to recompile 1,000 classes, redeploy everything. You might want to say, well, I can do that automatically via some script, via some shortcut with keyboard. Yes, we can do that, right? We can do that. But it doesn't solve different problems that we are going to talk very, very soon. We are going to cover those very, very soon. There is also another issue. Do you think that logger is the only dependency, the only common dependency, shared dependency that we are going to use throughout our entire software? I bet that not. We are going to use different things. Probably we are going to use like a private payment gateway in different places. We are going to use what else? We are going to use probably some authentication mechanisms like authentication manager again in different places, blah, blah, blah. We can one by one initiate them with our default constructor and then change everything if we want to replace the implementation, but that's not something we want to keep track of. That's not something we want to maintain. So maybe if I have one place that decides what's the current implementation of logging, one place that decides what's the current implementation of payment gateway, and in the same manner, one place which decides where is the current implementation of authentication manager. Well, let's call it logger factory. Why not? And now if I have a method which says logger get logger, let's call it get logger, I will just return new file logger, if that's our current choice, of course. Well, so far so good. Of course, now we have to replace logger factory here dot get logger, and now we are good, right? So now I can have a dependency to logger factory everywhere instead of having dependency to the current implementation. This I might be able to change it in one place if I need to do so. All right, but what's going on with the other types like authentication manager, like payment gateway, and so on and so forth? In the same manner, I can have payment gateway factory get payment factory, or get payment gateway to be more precise. Let's say we have now just one implementation, new payment gateway, doesn't compile, we don't care about this, we have to pass dependencies, let's forget about it for a while. In the same manner we would have authentication manager, and so on and so forth, blah, blah, blah. And all of a sudden we have 1,000 or 500 or 100 classes which are factories. Again, it's kind of hard to keep track of all of them at the same time and to maintain all of them. So a nice idea would be, hey, can't I have just one factory for every type? In that way, I would call it maybe type factory, and those methods I would move to here, like this. I will have to delete that. I will have more and more and more methods. Probably it's even better to have one generic method so that this class doesn't grow, but there is also another problem. Like each time we call the getLogger method or getPayment method, we are creating a new instance of the object. What's the point? I can reuse the console logger. Well, I can reuse, I want to reuse the same object that I have created. So maybe if I put it once somewhere, logger, then I can just reuse this instance that was created beforehand. Well, to implement that, I would need some kind of a memory. Let's have a memory in a hash map. Why not? So I will have different classes, different types, and different objects. So maybe hash map with a key of class to object. Let's call it objects, or maybe beans, or maybe types or implementations. I don't know. Let's stick to objects. Import. When I want to put a new class, actually I can put not only logger, I can put anything, right? Probably an object. Let's call it O. Get class, O. All right. Needs to be static, I guess. Cool. So what's next? Well, if I want to get class, I can have one generic method as we already stated. Let's do it that way. Get type. It's going to return, fingers crossed because I'm not good with generics, I guess T extends object, right? And that way we are solving the problem of not reusing our implementations. I have one implementation and one instance of each type. Objects get class. Oops. So far, so good. Return objects get class. Maybe we need to pass T as well here. All right. So far, so good. So next thing that we want to do is to think about how complex this class is going to be. Well, maybe if we now remove dependency to logger factory and replace that with type factory, that's not going to be a get logger class right now, but get type logger class, right? That's better. And well, this returns T, of course, right? Let's remove this. Maybe that's slightly better. We have one type factory instead of having 300 factories, and we can reuse instances of maybe heavy objects, right? So let's step back from this implementation for a while and see what we can do with it. Well, can I, for instance, teach my payments details provider to have a different implementation of logger just for the sake of testing without having to touch this class? I guess no, at least without some dirty tricks. Can I pass a different implementation for different instance of my application, maybe because I want to have a multi-tenant architecture? Well, I guess again, not. But I could do something like this. Maybe if I have an if statement here, if testing environment, then return something from the testing environment, like objects, maybe test objects. I will have a different hash map like this. Oops. And otherwise, I will just return what we wanted to return previously. So we start to have some sort of a configuration with this if statement. This if statement, imagine it's more and more complex. Like for this client, for this application, return that. For this testing invocation, return this, and so on and so forth. Depending on many different variables, like what is on your class path, or maybe what is in your .properties file, and so on and so forth, you can use different objects, right? So you can actually configure outside of your code what the application will return. But let's get back to testing. Can I test that? Can I test with a different implementation of logger? I guess not. And the other drawback is that now we have one mega gigantic function. This function it's called getType, and one mega gigantic class type factory that knows about all of the classes used by our program. Also, all of our classes know about this type factory, so it becomes a God class, it becomes a smell. No one wants to touch this class, because if we break anything in there, probably many different places, if not all of them, in our application will be broken. So maybe if I have some sort of orchestration that would pass to me all of the dependencies I need from the type factory, in that way I will have just something like this. As you can see, now we don't have any dependency to type factory at all, and for the testing purposes I can, for instance, I don't know, inject test logger. On production I can inject implementation which is equals to file logger, or maybe in other different circumstances I can inject console logger depending on my needs. And now, no dependency to type factory. Probably there is some sort of a place in our program near our main function that would have to wire up all of the dependencies, taking a look at the type factory. All right, so notice that now our dependencies are injected instead of having to look up for the dependencies from the type factory. These are injected and we don't have to care about those. All right, and this is the basic idea behind dependency injection. Objects are designed in a manner where they receive instances of other objects from other pieces of code instead of constructing them internally. What's the benefit? Well, first of all, and first and foremost, decoupling. By decoupling, we mean decoupling of the creation of the object. In other words, separate usage from the creation of the object. So how do we create? I don't know. I care how I can use that object. Also, it gives us ability to replace dependencies without changing the class that uses this dependency. For instance, for testing purposes, speaking about which, it makes our code more testable. It gives us architectural driver, which is called testability. Because we have now ability to create and use mock dependency during test. If we want to use a mock of logger during test instead of a real instance, we can create mock logger object and let our dependency injection, if we use even a framework, so dependency injection framework, inject that to our payment details provider. By the way, so far we have seen injection type via constructor. Probably you are familiar with the other types like property-based or setter-based. The most, I would say, recommended one, it's via constructor. It's via constructor. So now let's go back to code and take a look about one more thing. We can call those object beans. We can call our type factory our application context, for instance. And now we have some sort of a code which we can treat as a framework, and our business code which doesn't care about this application context part. So in other words, the dependency points from application context to payment details provider and every different class. So this is not even close to how complex Spring and Spring Dependency Injection Container is, but it gives you some sort of an insight of what it's for, what problems does it solve, because this is actually what dependency injection frameworks like Spring do. Instead of having our objects passed through new invocation and new instance creation, we declare that we need a dependency, and our dependency framework creates our object and pass to our object all of the needed dependencies. So, by the way, dependency injection, acronym for that is DI, is one of the ways of doing so-called inversion of control. So if you have heard about Spring IoC Container, this is exactly what Spring IoC Container is. Of course, very, very, very simplified. IoC means inversion of control, where basically the flow is inverted. The flow of the program is transferred to a container or framework. It's most often used in the context of object-oriented programming, right? Traditionally, our code made calls to some sort of a library, but IoC enables a framework to take control of the flow of the program and makes call to our custom code. To enable this, our frameworks like Spring use abstractions with additional behaviors built in. That's why, for instance, if I do this, or if I do XML configuration, which we shouldn't be doing right now because, well, it's XML. But if I do an annotation, if I provide a configuration class, I will register a bin, and Spring will know that this should go to application context, to the container, and will create a bin managed by Spring. And then we can choose how we are going to inject the bins. In here, we are injecting them via constructor. All right? So other ways of doing IoC, because we said that inversion of control, by the way, one more time, it's a generic term, meaning that rather than having the application call the implementations provided by a library, a framework calls the implementation provided by the application. And DI is a form of IoC, but we have different implementations of IoC. For instance, eventing. If you throw an event, we invert the control of the program, right? Because the class that handles the event will now take over. Same with aspects. Same with, for instance, strategy pattern. These are all ways of doing inversion of control, and dependency injection is a form of inversion of control. And to sum it up, with Spring, if you have your business object, your pure old Java object, POJO, payment title provider, and you pass some configuration metadata, take a look at here, like testing environment or those annotations, you will have a bin managed by Spring. So the container takes the POJO, some configuration, and creates a bin. Ready for use, fully configured system. All right? So that was a very short and quick introduction to what Spring is. So I have recently gotten to know that by our I mean people's attention span shrinks and shrinks every year. So we are, especially in the COVID-19 circumstances, not able to hear about one specific topic for more than half an hour, or even 20 minutes, or even 4 minutes, or even 40 seconds. That's how short our attention span is right now. If you want to know more about IOC, about dependency injection, I would strongly encourage you to read Spring's documentation. It's very well written, nicely explained with good examples, and plus you will understand what's going on under the hood of your application if you are a Spring user or Spring Boot user. If you are not, don't worry, because those concepts are not exclusive to Spring. These are actually well-known concepts like dependency injection and IOC, which are popularized by Spring, of course, but you can read about them even though if you don't use Spring, but I strongly encourage you to use Spring as well, because, well, that's the best framework to implement those concepts. So that's it. If you have any questions, again, the best way to reach me is via Twitter. You can see my Twitter handle in the left bottom corner of the slide. It's at Jakub Pilimon. My DMs are open, so that's the best way to reach me. If you have any questions about this, about any previous episode, and again, a friendly reminder, every Wednesday, Code with Tanzu, 12 Pacific time. See you next week. Mark your calendars. Have a great day, great evening, great afternoon, or good night, depending on where you are. Bye bye.